Hello everyone, in this video let's discuss about the ripple carry adders in the digital logic design. You can call these ripple carry adders as the parallel adders also. So why you will be calling these ripple carry adders as the parallel adders means we will be using the series of full adders here. Series of full adders. To design this circuit, we will be using series of full adders. Here, the output of one full adder will be acting as the input to the next or the adjacent full adders. In the series of full adders which we will be using to design the ripple carry adder, one output of the full adder will be acting as the input to the another or the next adjacent full adders. Now, these ripple carry adders, we can use them for adding the binary bits, that is addition of the binary bits. So what are the binary bits? Binary bits means 0 and 1s. So they are used for the addition of the zeros and ones, that is the binary bits. So now let's design the ripple carry adder circuit. So I will be using 4 full adders to design, 4 full adders. So we also know that in full adders we will be having 3 inputs. So one will be of A and another one will be of B and another one will be carry input. At the starting I will be taking the first adder here. So this is the first full adder, second full adder, third, fourth, like this. So at the starting the carry input will be equal to 0 since it is the first full adder I am having. Now what are the outputs we will be having in the full adders? We will be having sum as the one input and another we will be having sum as the one output and another output will be carry. So this is of the first one. So C1 I will take. As I said earlier, the output of one full adder will be acting as the input to the next full adder. So this is of A0, B0. Now let's write for A1 and B1 and C1 is the another input, that is total 3 inputs and the output will be S. This is of S0, this is S1 and another output will be C2, that is carry 2. This is carry 1, this is carry 2 and the inputs for the next one are A2, B2, C2 and the outputs will be sum 2 and carry 3. Now let's write for the next one, that is A3, B3 and C3 are the inputs. Outputs will be sum 3 and carry 4. It will continue as it is like this only. Now let's take the example so that you will be understanding much easily. So 4 adders are there. So I will be using 1, 1, 0, 1 and you must add 1, 1, 1, 0 to this one. So 1, 1, 0, 1 plus 1, 1, 1, 0 using the full adders. At the starting carry input is equal to 0. Now if you add them 1 plus 0. So 1 plus 0 will be 1 itself. So the sum value will be equal to 1 and you not took any carry, so carry value will be equal to 0. This carry value 0 will be acting as the input and another 2. This is of A values, this is of B values. So now the A value is 0 and the B1 value is 1. So 0 plus 1 will be, it will be equal to 1 because carry is 0 no. So 0 plus 0 plus 1, it will be 1. So sum is 1 and carry we not took, so it will be equal to 0. Now 1 plus 1 will be 2. You can't represent 2 like this using 1 and 0. So how you will represent means 2 powers you must be knowing, 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 0 means it will be equal to 1, 2 power 1 will be 2, 2 power 2 will be 4, 2 power 3 will be 8. You want to represent 1 plus 1, that is 2. So what you will be doing? You will be taking 2 and you will be not considering 4, 8 and 1. So we also know that whenever the non-zero elements will be starting, you must be taking the zeros after that. You should not take the 0 which are before the non-zero element. Non-zero element means other than the 0. So 1 is other than 0. After that right side you must take the value. So 1 and 0. Here 0 will be acting as the sum and 1 will be acting as the carry. So we will represent 2. 0 will be the sum and 1 will be the carry when you add 2. Now let's represent 3 because carry value will be equal to 1 and sum is equal to 0 in the third condition. Now for this one the input is C3, that is 1, and A value is 1, B value is 1. So carry is there 1 1. So total 3. You want to represent 3, how you will represent? You need 2 plus 1. It will be equal to 3. You don't need 4 and 8. So whatever the values which will be starting from 1, and if the zeros are right side towards the 1, you will be taking that one also. So 1 and 1. This one will be acting as the sum and this one will be acting as the carry. So sum is 1 and carry will be 1. Sum will be equal to 1 and carry will be equal to 1. So this process continues till how many parallel adders or the full adders you are using. So in this video we looked at the topic of the ripple carry adders, but this is the basic one, and the advanced one is carry look ahead adders, and it is the improved and the fastest output giving technique. So we will discuss it in the next video, and the video link will be given in description. You can access it. If you liked the video, please subscribe and support us because your one support motivates us to make more engineering related videos. Thank you.